correspondence and functions. So first of all, correspondence is sort of a relationship between two sets. A relationship between two sets. That's what a correspondence means. Okay, that's the definition. All right. So let me give you an example. Let's create a list, or sort of a set of people in a class. People in our class. So I can have a list of names, right? Okay. And then I can have another set called date of birth. And I could say, if I include myself in the first set, I could say people in our class named Christine, okay? And then I correspond to date of birth, December 5. I'm not going to tell you the year. Okay. So you can see, and each person in here would have a name and then a corresponding date of birth, right? And all of the names would be one set, and all the dates of birth would be another set. Everybody good so far? Okay. So now, based on that, is it possible for two different people from the first set to have the same date of birth in the second set?
Yes.
Yeah. So the list could be the same size or different sizes, right? And is it possible for one date of birth to correspond? No. I already said that. So you can have two people corresponding to one date of birth. Can you have two date of births corresponding to one person? No. That's crazy. I like that answer. Okay. So you can see that some of these things can have certain relationships. Like you can have two things going this way but not the other way, okay? So let's see here. A function is a special kind of correspondence between two sets. A function is a special kind of correspondence. Between two sets. Okay. The first set, okay, so just to define the sets, there's two sets. The first set is called our domain. Definition. Domain. The set of input values. Okay? Like I can say somebody's name in here, that's their input value, and then their date of birth would be their output value. The output value, the set of output values is called range. Normally, we would think of this as Christine and then give her date of birth, right? Normally, we don't start with the date of birth and then say Christine. Okay, so that's sort of the relationship here, but you know, okay. All right. There's, so we said a function is a special kind of correspondence between two sets, in this case, the domain and the range. So it's a correspondence between the domain and range. And it's a special kind. Let me explain what's special about them, about a function. It's not just any correspondence, but it's a correspondence where there is exactly, for any member of the domain, so for a function, each member of the domain corresponds to exactly one member of the range. Each member of the domain corresponds to exactly one member of the range. That's a kind of special correspondence. It's called a function. Okay. So, to explain that further, a way to remember the definition of function is this. This is a Christinism, okay? Ready? You can't kill two birds with one stone. You can't kill two birds with one stone. Okay. It's an easy way to remember if you can remember that sentence. In other words, you can't have two members in the range corresponding to one member of your domain. Okay? You can't kill two birds with one stone. So let me give you some examples to kind of solidify what that means. Okay, I'm going to make a list for my domain, a list for my range. My domain contains the numbers 4, 1, and -3. And my range contains the numbers 2 and 5. And my correspondences are as such. 4 corresponds to 2. 1 corresponds to 2. Positive 2. Oh, -3, yes. And -3 corresponds to 5. That's my correspondence, okay? And now the question is, so everybody kind of get the idea that there's a domain set and a range set? Everybody see that? Okay. And that there's a correspondence between the two? If I input 4 into my correspondence, out comes a 2. Okay? If I input a 1, out comes a 2. And if I input a -3, out comes a 5. Okay? So now the question is this a function? Did I kill two birds with one stone? So is it a function? What do you guys think?
Yes.
Okay, so I took 2 stones, 4 and 1, and killed 1 bird. Right? I killed the same bird twice. But did I kill 2 different birds with one stone? The birds are on the right. No, I didn't. The 4 didn't go to 2 numbers. It only went to 1 number. The one.
D stands for duck, right?
D stands for duck. Okay, so is this a function?
Yes.
Yes, it's a function. Because every member of D only went to 1 member of R. Sometimes the same member, but it only went to 1. You see, 4 didn't end up hitting 2 birds. Yeah, 4 is my stone, 2 is my bird. Everybody good? Okay, what about this one? Let's try a different example. Here's my domain. Ford, Chrysler, and GM. Okay, and my range, Sebring, I've never heard of. Is it? F-150 pickup. Malibu, and cobalt. I'm not a car person. Can somebody tell me what Ford corresponds to? F-150. Can somebody tell me what Chrysler corresponds to? And can somebody tell me what General Motors corresponds to? Both of those. Oh, see, you guys are good. Is this a function?
No.
Did I kill 2 birds with 1 stone? I killed Malibu and Cobalt with 1 GM. You guys see that? I killed 2 birds with 1 stone. Maybe I should write stone, birds.
Oh.
Your whole theory is wrong. Does that clarify it? I killed 2 birds with 1 stone. I killed a Malibu and a Cobalt with a GM. So is it a function? No, not a function. On the bright side, I want you to notice something. Every function has fun in it. So we talked about what a correspondence is. We talked about what a domain and range are. We talked about what a function is. Now, the last piece here is I want to talk about what a relation is. Relation. This is a definition. A relation, make it full screen, sure, is a correspondence between 2 sets, the domain and the range, such that each member of the domain corresponds to at least 1 member of the range. Each member of the domain corresponds to at least 1 member of the range. That's called a relation. Yes. Okay, so let me give you an example. So let's look at part 2C here in the book. It says so you've got a domain, you've got a correspondence, and you've got a range. So in my domain example, you've got authors of best-selling books. Authors of bestsellers. And then you've got your correspondence. The correspondence is the titles of the books written by each author. And then you've got your range. Range is just a set of book titles. Okay. So the domain we already know is, where you're starting, the input. The range is where you're ending, the output. And then the correspondence tells you how they're related. Is that okay? So you've got your authors, you've got your books, and they're related by which author wrote which title of the book. Okay? So now, is it a function? Is it a function? Can you kill 2 birds with 1 stone here?
Yes.
How?
Well, one author could write 2 books.
Uh-huh. So is it a function?
No. You can't see that.
Function? Is it a function? No. Because of what he said. One author can write multiple books. Okay. Everybody good on that? Okay. Is it a relation? In other words, looking at the definition of relation, each member of the domain, so each author, corresponds to at least one member of the range. Is that true? Well, if they're a bestseller author, that means they've written a book. Right? That means they have a title. So every author has a title corresponding to them, right? So that's what makes them a range, so a relation. Yes, because each author has at least one title. Right, a book title, right, is what we're talking about here. So does that make sense? You guys see the difference? So it's not a function because one stone can kill 2 birds, right? You can have one author and 2 books, okay? But it is a relation because every author has a book, okay? At least one book, right? Sometimes more. All right. So, functions and graphs. How does this all relate to math, right? Doesn't sound like math to me, does it? Sounds like books. Okay, how does this relate to math? All right. You can think of a graph as a set of x coordinates and a set of y coordinates, right? Right? So every point has an ordered pair, x comma y, right? And then the whole graph has more than one point. All of your x values, all of the x values would be your domain. All possible x values. And all your y values would be your range, your output values. All possible y values. And a graph, similarly to what we were talking about earlier, could be a function or not. Okay? It could be a relation or not. Okay? It's a function. If you remember what the sentence was, you can't what? What's a function? You can't kill 2 birds with 1 stone. So you can't have 2 x values correspond to 1 y value. Right? Because x values are your stones, y values are your, wait, you can't kill 2 birds. I'm so sorry. Can't kill two y values. Can't have 2 y values correspond to 1 x value. My bad. Right? Your all possible x values, those are your stones, right? All possible y values, those are your birds. Okay? So you can't kill 2 birds, 2 y's, with 1 stone, 1 x. Better? Okay. So, let me give you an example. Let's start with some ordered pairs. Let's look at the graph, actually. So, I've got, the first example here is this graph I'm going to go ahead and just list the ordered pairs there. What are my ordered pairs? I've got -3, 5. I've got 1, 2. And I've got 4, 2. Is that okay? For my first graph. So now looking at that, what is my domain? All the possible x values. Can somebody tell me all the x values? Okay. And what's my range? 5 and 2. Those are the only two, right? Okay. Everybody good so far? And we've got -3 corresponding to 5. You've got 1 corresponding to 2. And you've got 4 corresponding to 2. Okay. So far so good? All right. So, now looking at this, is it a function?
Yes.
Yeah. So what do I have here? I have 2 stones hitting 1 bird, right? 2 stones hitting 1 bird. But did I kill 2 birds with 1 stone? No. So is it a function?
Yes.
Yes, this is a function. Is it a range? Is it a relation? Is it a relation?
What's a relation?
Does every single domain have somewhere to go?
Yes.
Then that's a relation. Okay. From the picture, from the graph, looking at this graph, you can see that the x value, so for the x value -3, you've only got 1 y value 5. Okay? You don't have -3 comma somebody else. Okay? And for this x value of 1, you've only got 1 y value of 2. Right? And for this x value of 4, you've only got 1 y value of 2. You don't have more than 1 y value. You guys see that? You have the same y value twice, but not more than 1 y value for an x. That's what a function is. Okay? And then here's another function. You guys can see that -2 has only 1 y. X equals 0 has only 1 y, 0, 0, right? And x value of 1 only corresponds to 1 y value 1. And x value of 2 only corresponds to 1 value of 4. Okay. So when would a graph not be a function? So let's look at that. Let's look at a sort of quick and dirty way of looking at a graph and figuring out whether that graph is of a function or not. Okay? That's called the vertical line test. I'll call it VLT. But I'm starting to get hungry from that. Okay, vertical line test. If a vertical line hits the graph more than once, it's not a function. If a vertical line hits a graph more than once, the graph is not a function. So a vertical line can't hit the graph more than once. Okay, so I'm going to draw some pictures here. Or attempt to anyways, right? Okay, so. Yes. Okay, so examples. Here's my x-axis. Here's my y-axis. And I'm going to draw a line. And I wish I had like a ruler or something. So if you run this pen along, you'll notice how many times does the pen hit the line that I drew? Once. And keep going. Once, 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 right? It can't hit the line more than once. It would have to bend over and go back, right? So is this a function? Yes. It's a function if it only hits it once. Okay, let's call that A. B, let's try here's my next one. There's my graph. I'm going to run my vertical line test across that graph. Does the vertical, how many times is it hitting the line, the graph?
Continuously.
Once, right? Though, this vertical line only hits it once,
Oh, that one.
at one spot. Look at the vertical line, the pen, and see where it's touching the graph. It only is touching it at one spot, right? Keep moving it. Huh? Even here, it's only hitting it at 0, 0, right? And then it's only hitting it at one spot at any one, you know, and any vertical line is only hitting the graph once. So is it a function? Yes. It's a function. What about something like this? Okay. Check this vertical line out. How many times does it touch the graph? Twice. Is it a function? No, not a function. What do you think? Not a function. Because a vertical line would hit it more than once, right? Would hit it at 2 points in this case, right? If any vertical line would hit it more than once, then that's not a function. Here's a vertical line. It's hit more than one spot. Not a function. Everybody kind of see how the vertical line test is good for a quick check on a function if you've got the graph? All right. Okay. So now, naming functions. Okay. So, sort of, if a correspondence is a function, then we sometimes talk about, use a notation f of x. Okay. This is read f of x. Okay. And it does not mean, even though we're using parentheses, that parentheses is not a multiplication symbol. It does not mean the same as f times x. Not f times x. Okay, and I'll explain what it means. F of x means whatever's inside the parentheses is what you're inputting into your function, and then the value of f of x is what the output is. So let me give you an example. If I have an ordered pair 2, 5, okay? Another way of writing this ordered pair. Another way of writing this ordered pair is f for function, parentheses. What's my input value? What's my x value? 2. And then you say equals, and what's the output value? 5. These two mean the same thing. 2, 5 and f of 2 is 5 mean the same thing. It means you put 2, and visually speaking, 2 goes in, 5 comes out, and this is my function f. Okay? All right, so, for example, say again? So, for example, let's look at f of x equals 2x plus 3. Okay? And the question says find f of 4. Okay, what does this mean? What this means is you have a black box. We're naming him f. And what f does to things is what? It multiplies with the input by 2 and then adds 3 to that. So what I'm asking is if you stick in an x, what's it going to do to x? It's going to double it and add 3. 2x plus 3 will come out. If you stick in a 4, what's it going to do to 4? Double it, what do you get?
11.
8 and add 3, you get 11 out. So what's f of 4?
11.
Equals 11. Another way of thinking of it in terms of XY charts, y and f of x mean the same thing. Y and f of x mean the same thing. If I plug in 4, what comes out? What's y? 11. So f of 4 is 11. We call it f of 4 because that's what I replaced. That was my input value. Does that make sense? Okay, let's try another one. This is a kind of funky one. I can use different letters for my function. I can say h of 4, where h of x equals 11. So, machine-wise, I plug in an x, out comes a, what does this h of x equals 11 mean? It means I'm plugging in x and out comes 11. If I plug in a 4, what do you get? Well, this one's kind of funny. It doesn't matter what the heck you put in. What's going to come out? 11. You were right. You were thinking right. You just didn't want to say it. This is a kind of funny function because it doesn't matter what you put in, 11's coming out. Everybody good with that? Okay. And then one last one. Big F of parentheses a plus 1 equals. Oh no, that's what I want to find. Sorry, that's what I want to find. And my function is f of x equals, big F of x equals 2x minus 7. Little f and big F don't mean the same thing, okay? But they're both different functions. So, what's it asking for? I know that if I plug in x, I'm going to get a 2x minus 7 out of it. Now it's asking, what if you plug in an a plus 1? What comes out? Well, 2 times whatever you plugged in, right? A plus 1 minus 7. Is that okay? I replace x with whatever it is, a plus 1 in this case. And what do you get? 2a plus 2 minus 7, or just 2a minus 5. So f of a plus 1, f of a plus 1 equals what? Okay.